Welcome, my dear learners, for this course on engineering graphics. In this module 2, we were discussing on orthographic projection of plane surfaces. So far, we have solved 28 problems on orthographic projection of plane surfaces. Moving ahead to the final lecture of our discussion on orthographic projection of plane surfaces, the problem number 29 states that a circular lamina of 50 mm diameter standing on one of its points on the rim on HP, and the lamina is inclined at 45 degrees to HP. The diameter at right angles to the diameter which is passing through the point on which the lamina rests is parallel to VP. The resting point is in both HP and VP. Draw its projection. We have a circular lamina resting on HP. So therefore, let us draw XY line. So first let us draw XY line and draw the lamina in the horizontal plane. Since the lamina is resting in horizontal plane, the second position should show inclination with respect to HP itself. That you people already learnt. So this is X, we have VP and HP. Draw the circular laminae of diameter 50 mm. So measure radius of 25. Measure radius of 25 and draw a circle. Measure radius of 25 and draw a circle. So measured radius of 25 and a circle has been drawn. Done. So we have drawn a circle of radius 25 mm. Now as I said, divide this into 8 equal halves. You can also draw it by dividing into 16. So let me do it with 8 equal divisions on the circumference by taking 45 degrees, 45, 90, 135, 180. So similarly we have minus 45, minus 90, minus 135, minus 180. Now join these divisions to get the points on the circumference. So connect 45 with minus 135. Similarly 0 and 180, 0 degree and 180 degree. Then you connect minus 45 with plus 135 and we have plus 90 and minus 90. Done. Now mark the points. We have A, B, C, D, E, F, G and H. Now take the projection. So take the projection and complete the front view. So the front view measures 50 mm because it is the diameter, correct? Front view measures 50 mm as it is the diameter. So we have A dash, B dash, H dash, C dash, G dash, D dash, F dash and we have E dash. So the lamina is inclined at 45 degrees to HP. So show 45 degrees inclination, measure 45 degrees, measure 45 degrees and draw 50 mm, draw 50 mm, drawn at an angle of 45 degree, 50 mm drawn and show, mark these points also. So mark all the points and also we have points at center, exactly center, right? So we have A dash, B dash, H dash, C dash, G dash, D dash, F dash and E dash. The angle of inclination is given as 45 degrees. Done. Now take vertical and horizontal projection and complete the drawing. We have A dash to A, B dash, H dash, G and C at the center, D and F, and finally we have E dash. Right? So take the projection. So take horizontal projection and mark the points. So once it is done, draw smooth curve. Draw smooth curve like this. Done. So this is A, B, C, D, E, F, G and H. Now he says that diameter right angles to the resting diameter. It is resting on diameter AE. The diameter which is right angle to this is GC. Correct? So this GC should be parallel to VP and the resting point is A. So A should lie on both VP and HP. Correct? So therefore first draw AE which is perpendicular to GC such a way that A is in both VP and HP. So therefore draw AE first. Draw AE first. Drawn. I drawn AE. Now GC is parallel, and one more observation is that GC is retaining its original dimension which is 50 mm given in the question. So the diameter is retained throughout the problem which is 50 mm. Now draw GC parallel to VP. Now GC is parallel to VP. Done. So A is on both VP and HP. GC is parallel to VP. So this will become C and this will become G. This is A and this is E. Right? Now transfer the remaining points using compass. That is CD, and from G also you draw the arc. Now from A you measure this and intersect. Done. Now draw smooth curve to complete the drawing. That is, we have from A done. So this is B, C, D, E, F, G and H. Now take vertical and horizontal projection and complete the sketch. So we have from C, then we have D and B, then A and D, F and H, and finally G. So draw horizontal projection and locate the points. We have B and H. Now draw smooth curve. It will be like this. Done. So So this is A dash, we have B dash, C dash, D dash, E dash, F dash, G dash and H dash. So this is the solution for problem number 29. This is the solution for problem number 29. Wherein which the diameter, right angles to the diameter is parallel to VP and the point on which it rests is in both VP and HP. Now moving ahead to the final problem of our discussion on this module 2, problem number 30 states that a circular laminae inclined to VP appears in the front view as an ellipse of major axis 30 mm and minor axis 15 mm. The major axis is parallel to both HP and VP. One end of the minor axis is in both HP and VP. Draw the projection of the laminae and determine its inclination with VP. Now we have a circular laminae which appears to be an ellipse in the front view. So therefore I want to have a circle first which appears to be an ellipse in the second position with the major axis 30, minor axis 15. So since the major axis is 30, first I should draw a circle of diameter 30 mm. It is appearing as an ellipse in the front view, so therefore I should draw a circle in the front view. Front view is always plotted on vertical plane. Come, let us solve this problem. First let us draw XY line. Draw XY line. Draw XY line. So this is X, this is VP and HP. Now draw a circle whose diameter is equal to major axis of the ellipse, which is 30 millimeters. So taking 15 mm as radius, draw a circle. Taking 15 mm as radius, draw a circle. So I am drawing a circle by taking 15 mm as radius. Done. No need to divide this into 8 or 16 equal halves because it is appearing like an ellipse. So just I want major and minor axis. Now for circle, both the axes are nothing but the diameter, which is same or constant, which is equal to 30 mm, right? He has given the diameter as 30 mm for us. So mark the diameter. Mark the diameter. So this diameter is given as 30. So this is solution for problem number 30 and this is solution for problem number 29. Now let me mark this as A dash, B dash, C dash, D dash. Now take the projection. So I'll take the projection. The laminal length is equal to the diameter, which is 30 mm. Correct. So this is A, D of B and C. Done first position. Second position is it is appearing like an ellipse, right? So ellipse of major axis is how much? 30. So take the major axis you retain as 30. So take 30. You retain the major axis as 30. So retain the major axis as 30. Retained. Now we have minor axis as 15. Now we have minor axis as 15. Now retain the major axis as 30. Now mark minor axis as 15. So minor axis is 15, that is 7.5, 7.5 on either side. Mark 7.5 mm, 7.5 mm on either side. So mark the minor axis. Major axis 30, minor axis is 15, 7.5, 7.5 on either side. So that will gives us again A dash, B dash, C dash, D dash. Hope you followed. Take the major axis, take the projection, mark the minor axis as 7.5, 7.5 on either side at exactly center. So major axis is 30, minor axis is 15. Now draw ellipse. So draw ellipse. Done. Ellipse is drawn. Now take the projection from A dash, you take the projection from C dash, you extend it, because once I incline this to vertical plane, it is appearing like an ellipse. So therefore I want to find the inclination. So keeping at AC, which is equal to 30, cut an arc. Now join this, that will give you the inclination. So this is A, this is C. Now projecting this gives us D and B. Now measure the angle, that is what he has asked. How much it is measuring? It is measuring exactly 60 degrees. So I am getting the angle as 60 degrees. Means what? If I incline a circle of diameter 30 mm to an angle of 60 degree to vertical plane and take the projection, you will get an ellipse of major dia 60, minor dia 30. Sorry, major dia 30, minor dia 15. This completes the second position. What is the third position? He says that the major axis is parallel to both HP and VP. One end of the minor axis is in both HP and VP. So major axis is BD should become parallel to both HP and VP, and one end of the minor axis should touch both HP and VP. So let me take A dash touching HP and VP. So therefore A dash should come on XY line and D dash B dash should be parallel. So first let us draw A dash C dash, which is equal to 15, which is known for us. So draw A dash C dash drawn, and then you draw major axis parallel, that is exactly the center 7.5. You draw 15 15 on either side, 15 15 on either side. So that completes the ellipse. Done, right? So this is A dash C dash, which I had drawn at exactly center. I had taken 15 15 on either side, that is a major axis parallel to both HP and VP. This will become B dash, this will become D dash. Now take horizontal and vertical projection, that completes the problem. Taking vertical projection to D, this is till C and this is only till B. So we have B and this is C. Done. So draw freehand sketch for this ellipse. Done. This is the answer. This is A, B, C, D. So this is a solution for problem number 30. This is how we should solve problem on ellipse. No need to go for 8 points or 16 points, just with the 4 points we can complete the problems on ellipse. This is an indirect problem because the circle appears to be an ellipse. Find the inclination. At what angle if you incline a circle, it appears like an ellipse of major axis 30, minor axis 15 was the question, and the answer what we found out is, if a circle of diameter 30 is inclined at an angle of 60 degree to the vertical plane, the front view will become an ellipse of major dia 30, minor dia 15. And in the final position he says that one end of the minor axis should be in both HP and VP. That is correct. A is in both HP and VP, and major axis is parallel to both HP and VP. That is also correct. So this completes our discussion on orthographic projection of plane surfaces. From next lecture we are beginning a new module, that is in module 3 I will be discussing on orthographic projection of solids. That's all from this lecture. Thank you all.